So yesterday we talked about the addition rule and or probability. Today we're going to talk about the multiplication rule, which is and probability. So if you remember yesterday with the or probability, there were two types of events. They could be disjoint or they could be overlapping. There are also two types of events when it comes to the and probability or the multiplication rule. So independent events are when the outcome of one event does not affect the outcome of another, or when the result of one event does not affect the result of another. So how you can identify independent events when you're looking at a description of an experiment would be if, like, you draw a card, you look at it, and then you put it back before you draw another one. So with replacement, meaning you have the same stuff to choose from every time. Or if you're just doing two completely different experiments, like if you're rolling a die and spinning a spinner, the results of one are not going to affect the other because they're just two totally different things. Okay, and then we have dependent events, which is when the result of one event does affect the result of another event. So for example, this would be like if you drew a card and then didn't put it back before you drew another one. That would affect the result because the first time you drew a card, you had all 52 to choose from, so you drew your card, looked at it, but then you didn't put it back, which means the second time when you go in to draw a card, you'll only have 51 to choose from. So it's changing the possible outcomes, which would make it dependent events. So whenever you have without replacement would be dependent. Okay, so example one, just some practice identifying what type of events we're dealing with here. Example one says, suppose you flip a coin and roll a die. Are the events obtain a head and roll a 5 dependent or independent events? Does one affect the other? No, right? You're doing two completely different things. No matter what you get on the coin, that's the coin's separate thing. Rolling a die is not going to be affected by that. So that means these would be independent. Independent events because they're just two separate things. We're flipping a coin and rolling a die. Two different experiments. Okay, letter B, suppose you draw one card from the deck and then without replacing it, draw a second card from the deck. Are the events getting a heart the first time and a diamond the second time dependent or independent events? So what would this one be? Dependent, because we didn't replace the card. Without replacing means our total to choose from went from 52 to 51. Something changed. Our second event is going to be affected by that. Dependent because we didn't replace. if we put it back, if we drew a card, put it back, and then drew another one, that would be independent. Okay, so at the bottom here, just a quick side note of how disjoint and mutually exclusive that we learned about yesterday, how that is different than the independent events that we just talked about earlier. So it is important that you understand that these are two different concepts. Two events are disjoint if they have no outcomes in common, so there's no overlap. So if they have no outcomes in common or no overlap, that is, we know if one of the events happens, then we know for a fact the other one did not. And this is for or probability only. Events can only be disjoint if it's or probability. So again, like if we're rolling a die and we want to know the probability of rolling a 1 or a 3, that's or probability, and you can't roll a 1 and a 3 at the same time. It's not possible, which makes them disjoint events. Independence or independent events just means that one event occurring has no effect on the second event. Has no effect, it's a long line, on the other event occurring. That is, knowing the outcome of one event doesn't mean we know anything about the second event. All we know is that they're not going to affect each other, they're separate. We can calculate the probability separately. And again, you can only have independent events if it's and probability. So just make sure you're okay with the difference between those. Or probability, you're either disjoint or overlapping. And probability, you're either independent or dependent. All right. So now with this multiplication rule, again, multiplication rule is whenever we have and. Okay, so and probability when we do an experiment multiple times, or if we're doing multiple experiments. So if you remember with our or probability, that means we're only doing the experiment once, and we're looking for multiple outcomes. With and probability, we are doing the experiment multiple times, and we're looking for a specific outcome each time. Okay, so if we have two independent events, meaning they don't affect each other, so like we replaced the card after we drew it, or we're just doing two totally separate things like rolling a die and flipping a coin, then to calculate the probability of event A and event B occurring, then we would just take the probability of A and multiply it for the multiplication rule by the probability of B. So since they're independent, you just take each individual probability and multiply them together. Because it's and, we multiply. Okay, so the independent one is pretty straightforward. Now with dependent events, so again, this is where the outcome of one is affecting the outcome of the other. This is when we don't have replacement, so you draw a card and you don't put it back. To calculate this and probability, you're still going to have the probability of A, the probability of your first event. And you're still going to multiply because it's and. But then when we calculate our second probability, since these are dependent events, it's going to be the probability of B, assuming A has already occurred. Okay, so that just means, usually means your denominator is going to be changing, because if you drew your card from 52 but then you didn't put it back, our second probability now, we are assuming we only have 51 cards to choose from because we have one card that's no longer in the deck. So example 2 here. Suppose you draw one card from a deck of cards, put it back, so this is with replacement, which means we have independent events. Then the cards are shuffled and you draw 3 more cards the same way. So you draw one, put it back, draw another, put it back. You do that for a total of 4 times. What's the probability that you will draw 4 aces in a row? So in other words, you want an ace, and another ace, and another ace, and another ace. 4 aces in a row. And then since we're putting the card back each time, every time we calculate a probability, we will have all 52 cards to choose from. And since we have all 52 cards to choose from each time, how many aces are in a deck of cards? 4. So 4 would be our numerator each time. And then since it's and probability, that means we're going to multiply. Okay, so when you multiply, this is going to give you a pretty big number, well, a pretty big fraction. So if we multiply our numerator straight across first, so 4 times 4 times 4 times 4. And then our denominators. And again, you can leave it like this. Or if you want to plug it in and get the decimal, that's fine. It'll just be a very small decimal, like 0.0000 something. Okay, any questions on example 2? Okay. Example 3. You draw one card from a deck of cards, do not replace it, so we're not putting it back. So is this going to be an independent or dependent event? Dependent. And then we draw a second card. What is the probability that the first card is an ace and the second card is a king? So probability of an ace and a king. So when we go to draw our ace, we have all 52 cards to choose from, and there's 4 aces in the deck, so we'd have 4 over 52. Then we have the and probability, which means we're multiplying. But now since we have a dependent event, we didn't put our first card back. So we're assuming now that I have an ace in my hands and I'm not putting that back in the deck of cards. So now how many total cards do I have to choose from? 51. So your denominator would be 51. And how many kings are still in the deck of cards? 4, because the card that's not there is an ace. So all the kings are still there. So we still have 4 over 51. Okay, then again you multiply straight across. So numerators, 4 times 4 is 16. And our denominator is 52 times 51 is 2,652. So again, it's 1 less because we didn't replace it, because we didn't put that first card back. Okay, example 4. Probability that a randomly selected student is taking an art class is 15%. What is the probability that 3 randomly selected students are taking an art class? That means we want student 1 to take an art class, and we want student 2 to student 3 all to take art classes. When I'm giving you probabilities like this in percent form, when you're using the multiplication rule, we want to put it in decimal form. So multiply using decimals. So the probability that our first student is taking an art class is 0.15. Are these going to be independent or dependent events? Does the fact that one student takes the art class have anything to do with the second student taking the art class? Nope, they're their own people. They make their own choices. These are dependent events. So that means we can just take 0.15 times itself again, and a third time for all three students. So 0.15 times 0.15 times 0.15. Which will be something. 0.0034. Okay, so just to wrap it up down here at the bottom, again, the summary of the different probability situations. You can either have the and probability that we just talked about, which is where you're doing an experiment multiple times and looking for specific outcomes each time. First you draw a king, so you want a king first, and then you're drawing another card and you want a 2. You have specific outcomes. Whenever you have and probability, it's multiplication. And you can have either independent or dependent events. Those are your only two choices for and probability. They can only be independent or dependent. Or for and probability. Then or probability that we did yesterday, this is where you do the experiment only one time and you're looking for multiple outcomes on that one try. So you draw a card and you'd be okay if it was a king or a queen. Either one would be good, but both won't happen at the same time. This is where you add, and you would have either disjoint or overlapping events. Okay, so it's important that you know the difference between these.